this is our fourth example. And as we look, we see that we have sine and cosine. It's in terms of two trig functions. And we can't see directly any substitution that we could make because we don't have squares, so we can't use a Pythagorean relation. Sine and cosine are not reciprocal functions. So what I probably want to do is try to see if I can pull everything to one side. And get it set equal to 0. Because if I can get it set equal to 0, and if I can in some way factor, then I can use zero product property. So as I look at this, it's a binomial. We have two terms. And looking at the two terms, we look to see if there's something that they share in common. And they do. They both have a sign of alpha. And so if I factor out that common factor, you know, if you want to think of it as the yellow box, I'm going to factor out the yellow box. And so if I factor the yellow box out, and that yellow box contains sine of alpha, if I factor it out of the first term, I'm left with 2 cosine alpha. Minus, if I factor it out of this term, you know, you have to think sine of alpha times what gives me sine of alpha, and that would be 1. Notice it's still in terms of two trig functions. It's a term of sine and cosine. But it's okay now because it's written as a product. Each of those products individually, each of those factors, are individually in terms of a single trig function. This is in terms of sine, this is in terms of cosine. So now we can use zero product property because if the product is equal to 0, then this factor has to be equal to 0, or this factor has to be equal to 0. And then we simply solve. Well, sine of alpha equals 0. We'll stop with that. It has a coefficient of 1. We'll come back to that in a minute. This one I want to try to solve for cosine of alpha. And so if I add 1 to both sides, and then divide both sides by 2, I can see the cosine of alpha equals 1/2. So I really have two separate problems that I'm solving now to find alpha. This asks me, when is the sine of alpha equal to 0? So if I kind of think about it, well, that happens on the axis. Sine is equal to 0 here at 0 degrees, and then it's also over here again when it's equal to 180 degrees. So this will equal 0 if I have 0 degrees, the sine is 0 degrees, and the sine of 180 degrees is also 0. So far I have two angles. Coming to the other side, we're looking for when cosine of alpha is equal to 1/2. Okay? It's a positive ratio. We know that cosine is positive in the first quadrant. It's also positive in the fourth quadrant. And so ask yourself, when does sine have a ratio of 1 to 2? Or excuse me, when does cosine have a ratio of 1 to 2? And that happens when cosine is equal to 60 degrees. So in the first quadrant, I rotate up so I have a 60-degree angle. So alpha is equal to 60 degrees. That's the first quadrant. It could also fall in the fourth quadrant. And it would have that reference angle of 60 degrees. So how many degrees does it take to rotate around so that we stop right there? Well, we're short 360 degrees by 60, so alpha would be 300 degrees. So our solution, the values that will make our original true, alpha could be 0 degrees, 180 degrees will make it true, 60 will make it true, as well as 300 degrees. Going through, I didn't multiply both sides by one of my trig functions, therefore, and I didn't square both sides. I haven't caused any extraneous roots. Those are my solutions. Good idea again to double check, to make sure I haven't made any errors by plugging them back into the original and making sure that all four are truly my solutions.